Dr. Ranjani Parthasarathy is a professor in the Department of Information Science and Technology, Anna University. Her area of specialization is computer architecture and networks. One of her special interests is Indian language technology systems. She is actively involved in research in all the areas and has over 50 publications to her credit. She has about 25 years of experience covering both industry and academics.
Welcome to the UGC lecture series in computer science. This is a series of lectures in computer networks. Today, we will be looking at details of the ATM protocol, asynchronous transfer mode protocol. We know that ATM is a digital transmission system and it is basically used as a broadband ISDN protocol, or it is used in broadband ISDN networks, BISDN as they are referred to. So, what we will do now is take a look at the details of this ATM architecture. Okay. So, we have already looked at this basic layered architecture that is there in ATM. We will just do a quick recap of that. So, basically it consists of 3 different planes at which the model has been specified: user plane, control plane and the management plane. Now, if you look at the different layers that are there in each of these planes, we have what is called as a physical layer at the bottom, and then we have the ATM layer, then we have the ATM adaptation layer and then the higher layer protocols. So, if you look at the ATM layer, the virtual path functions, virtual channel functions, all these become part of this ATM layer. So, understanding the structure of the cell, understanding how virtual channel switching takes place or virtual path switching takes place, all these are functions of the ATM layer. This is something that we have looked at in a previous episode. Now, today what we will be looking at will be more on the ATM adaptation layer and how the control plane is used and the management plane is used in order to provide traffic management and various such other services. Okay. So, if you look at the AAL reference structure, now we said we have the ATM layer and then we have the ATM adaptation layer. So, this is where we are going to start. So, the ATM adaptation layer is referred to as the AAL layer. Okay. So, if you look at this AAL layer, the reference structure for the AAL goes as given over here. This AAL, below this you have the ATM layer and above this you have a higher layer. So, here these are the service access points that you have, one service access point with the higher layer and a service access point to the lower layer. In the AAL, if you look at the different layers that we have, there is what is called as a convergence sublayer and then we have something called a segmentation and reassembly layer. Now, you can see one of the primary functions of the adaptation layer is to take data coming in from the above layer and segment it into 53 byte cells. And obviously, if it does the segmentation on one side, on the other side it will have to do the reassembly. So, segmentation and reassembly is one primary job of the ATM adaptation layer. In addition to this, there is something called a convergence sublayer. Now, this part, this again is divided into 2 parts. It has something called a service specific convergence sublayer and a common part convergence sublayer. So, this is called as CPCS and this is called as SCCS. Okay. So, we have something called a convergence sublayer and then you have a segmentation and reassembly layer. Now, what is done by each of these will depend on what type of application it is trying to support. So, that adaptation with respect to ATM is taken care of by these 2 parts. To summarize what we talked in terms of this ATM adaptation layer, this in order to carry the data units which are longer than 48 octets in ATM cells, an adaptation layer is used. Okay. So, this provides for segmentation and reassembly of higher layer data units and for detection of errors in transmission. So, this is taken care of by this CPCS layer sometimes and also by the SAR functionality that we have. Since the ATM layer simply carries cells without concern for their contents, a number of different AALs can be used across a single ATM interface. Now, this is an important point to understand. There is the ATM layer which is responsible for carrying cells, does not bother about the contents of those cells. Okay. So, in order to provide for different types of data, right, or different types of content that you want to carry in these cells, you would have different types of AALs that would be used. And different type of AALs can be carried across a single ATM interface, which means you are providing for all types of data, voice, video and so on to all be carried together, and the adaptation is taken care of by the AAL layer. So, essentially what we can say is the AAL maps the user, control or management protocol data units into the information field of the ATM cell and vice versa, that is in the reverse direction. At the receiver side, it takes it from the ATM cell and does the mapping in the opposite direction. Okay. So, to reflect the spectrum of applications, 4 service classes were originally defined by CCITT. Now, CCITT is the standards organization which is responsible for providing this. So, originally what they looked at was they had 4 classes of applications. So, 4 distinct adaptation layers were thought of. Okay. So, class A basically is a constant bitrate application, what is referred to as CBR, constant bitrate. Second is variable bitrate application, class B, this is called as VBR, variable bitrate application. Class C is for connection oriented data applications and class D is for connectionless data applications. So, we had these 4 different categories A, B, C and D that was originally proposed in the ATM architecture. Of course, the moment I say it was originally proposed in the ATM architecture, it indicates that some changes have taken place to this. So, you look at what has happened after that. Okay. So, in this original ATM architecture, the AAL interface was defined as classes A to D with a SAP, that is a service access points for AALs 1 to 4. So, you had AAL 1, AAL 2, 3 and 4, right, and for these 4 different classes that we had. Out of these, AAL 3 and AAL 4 were so similar that they were actually merged into an AAL 3/4. So, it was kind of both were combined together. Okay. And finally, what happened was the data communications community concluded that AAL 3/4 was not suitable for data communications applications. So, they pushed for a different standardization. So, they came up with another one called AAL 5, which is also referred to as SEAL, a simple and efficient adaptation layer. Okay. AAL 2 was not initially deployed. So, typically it was AAL. So, now what has happened more is that we focus more on the AAL 5, the AAL 5 standard that is used for adaptation. Okay. So, if you look at the service categories and the different characteristics of these different service categories, so you can see what has happened. So, class A basically does circuit emulation and AAL 1 is the standard that is used for this. Class B is used for packetized voice and video. So, AAL 2 is the category that is used for this. Class C and class D, class C we said is for connection oriented data, class D for datagram. So, which used AAL 3 and 4. Finally, as we said, these two have been merged together and we have something called AAL 5. So, AAL 5 caters to both these classes, okay, and AAL 2 to this class, to class B, AAL 1 to class A. Now, what is interesting about the attributes or the characteristics of these different services is that we look at it in terms of whether timing is essential between the source and destination, whether the bit rate is constant or variable, and what kind of connection mode is used. Should it provide for a connection oriented service or for a connectionless service. Okay. So, class A and class B, in both these cases timing is important between the source and destination. So, timing is required, whereas here timing is not required for classes C and D. With respect to bit rate, class A is a constant bit rate application, B, C and D all use variable bit rates. With respect to connection mode, again A, B and C, these cater to connection oriented and connectionless is provided for class D. Okay. So, depending on these 3 parameters, whether timing information or timing synchronization is required between the source and destination, whether it is a constant bit rate or variable bit rate, and what kind of connection mode is preferred, connection oriented or connectionless, we actually have these different service classes or classification. So, now based on all these different changes that have taken place, the way we look at ATM service categories today is like this. So, this is our revised set of ATM service categories. So, here we talk now about CBR, which is constant bit rate, right. This is typically used for emulation of your T1 circuits and so on, time division multiplexing based standards that we have. So, this is a constant bit rate service category. Then we talk of a variable bit rate, but under variable bit rate we provide for 2 different classifications, RT VBR and NRT VBR. RT VBR stands for real time variable bit rate. This is used for some real time video conferencing kind of applications, And then you have the non-real time variable bit rate, which can be used for things like multimedia based email and so on. Because you are talking about variable bit rate data, you talk about multimedia data, but it is non-real time. It is not some live streaming that is happening, but it is being sent offline. Next category that we look at is available bit rate, ABR. Okay. So, what we mean by this is whatever available bit rate is there, that could be used. So, typically when you are looking at browsing the web, you are not looking for any specific guaranteed bit rate, but you use whatever bit rate is available to you. So, that is called as ABR. So, ABR is provided more for these kind of applications. And then we have something called UBR, which is unspecified bit rate. Okay. So, this is for some background file transfer and so on, where nothing has been specified. So, whatever unused capacity is there could be used by these kind of applications. Okay. So, today when we talk of ATM service categories, these are the categories that we try to provide for. So, CBR, which is constant bit rate, RTVBR, which is real time variable bit rate, NRTVBR, non real time variable bit rate, ABR, available bit rate, and UBR, which is unspecified bit rate. So, now for each of these different services that we have, right, different types of services that we have, we try to provide some criteria based on which the ATM service can be specified. That is, now you have a certain application which is expecting a particular service from the network. So, which means I need to have a contract between the network and the user saying that I am sending this kind of data. So, then the network says yes, I will provide you this kind of service. Okay. So, ATM also provides this service criteria and tells you how this contract can be designed. So, the service criteria as such is specified in terms of traffic and QoS parameters. We have traffic parameters that will have to be specified, and then we have quality of service parameters that have to be specified. Now, both this traffic and quality of service parameters, all these, remember, they are all part of the control plane of the data transfer. Okay. That is, they control how the data will actually be transferred by the network. Okay. So, if you look at traffic parameters, let us take a look at some of the parameters that are actually used to specify traffic and so on. So, if you look at traffic parameters, these are some commonly used terms in ATM. We talk about something called a peak sell rate, then we talk about a sustainable sell rate. Now, there is a difference between these two. Peak sell rate is what is the highest possible sell rate that you are likely to get. Sustainable sell rate is this sustainable rate, or normally, or what is the rate at which you expect cells to be sent. Okay. So, we have something called a peak sell rate and sustainable sell rate. Now, when you have variations in the sell rate, then you will have a peak sell rate and a sustainable sell rate, which could be different from each other. Okay. So, that is important to look at. Then we talk about maximum burst size and a minimum sell rate. Maximum burst sizes, when is it that you are likely to have a number of cells coming in at a very high rate together. So, those are the size of the burst. We normally say that data comes in bursts, right. So, what is the size of this burst, maximum size of a burst? And then we also talk about what is a minimum sell rate, that is, minimum cells will be sent at a particular rate. So, we have a minimum sell rate, a peak sell rate, a sustainable sell rate, and then we talk about a maximum burst size. All these are parameters which will help you to characterize the traffic that you have. Then, when it comes to quality of service parameters, we talk about the delay and the loss parameters. That is, how much of delay can we tolerate, how much of loss can be tolerated. So, with respect to delay, we talk about what is called as maximum cell transfer delay, or MCTD, and then we talk about a cell delay variation tolerance. That is, we allow for a delay and there can be some variation in the delay, but what is the tolerable limit for that? So, we talk about cell delay variation tolerance. Then we talk about something called a cell loss ratio, that is, given that cells are likely to be lost, okay, in any medium, naturally there could be some losses. So, what is the ratio, what is the cell loss ratio that can be tolerated? So, once you specify these traffic parameters and quality of service, then the network tries to provide a service such that your application is able to maintain its required mode of operation, its performance. Okay. So, to make sure that the performance is guaranteed, we have all these parameters that are provided by ATM. Okay. So, we will take a look at further details of how the traffic management is done. We now take a short break. Welcome back after the break. So, we have been looking at the different service categories provided by ATM protocol. So, we said we have something called constant bit rate, variable bit rate and so on. So, just take a let's take a look at what are the characteristics of each of these. So, we said constant bit rate. So, when I say constant bit rate, it means that fixed data rate continuously available, okay. And this also means that I have a tight upper bound on the delay, because data is coming in constantly. So, I cannot afford to have delay. So, it is a very tight upper bound on the delay. Typically uncompressed audio and video, video conferencing, interactive audio, audio video distribution and retrieval, all these are applications which typically require a constant bit rate. Now, if you look at real time variable bit rate data, that is RT-VBR that we looked at, this as we said is for time sensitive applications, tightly constrained delay and delay variation. Remember, there are two things we talk about, right? We talk about the delay and we also talk about the variation in the delay. Now, in many real time applications, you cannot tolerate too much of variation in delay, it will lead to what we call as jitter. So, in order to avoid that, especially in time sensitive applications, we need tightly constrained delay and delay variation. These are provided by the real time variable bit rate service category. Now, RT-VBR applications, they transmit data at a rate that varies with time. So, examples of this, which are the applications which typically use this, are compressed video, because you know that when we compress the video, sometimes you have more amount of data to be transmitted, sometimes it is less. So, there is a variable data rate that you have. So, it produces varying sized image frames, and the so typically what happens is the original frame rate is constant, the uncompressed frame rate is constant, but the compressed data rate will vary. So, these kind of compressed video applications, we make use of the real time VBR service category. So, this could typically multiplex different connections, statistically multiplex different connections. So, you are able to also handle more number of connections when you go in for real time VBR services. So, sharing of bandwidth is also a possibility with real time VBR. Okay. So, when you look at non real time VBR services, as I said, this is non real time. So, we are not looking at time wise too much of a constraint, but is normally used to characterize expected bursty traffic control, for example, airline reservations, banking transactions and so on. So, the ATM network allocates resources based on this, that is to meet the critical response time requirements, giving improved QoS in loss and delay. The end system will typically specify the peak cell rate, sustainable or average rate, and measure of how bursty the traffic is. So, remember we just talked about these different parameters. So, like this you will have parameters specified for each service category, okay, and based on that you specify what kind of services are required. Okay. The available bit rate category, now this we said is tries to use whatever available bit rate is there, but here again you specify what is the peak cell rate and what is the minimum cell rate that is acceptable. So, which means that you will have to say minimum I need so much of cell rate, otherwise I cannot handle the, I will not be able to transmit my data, and this is the peak cell rate, that is I will definitely not send more than this particular rate. Okay. So, this is how the available bit rate will be specified. So, the resources allocated to give at least MCR. So, at least a minimum cell rate service has to be provided by the network, okay. And the spare capacity will be shared among all ABR sources, okay. That is example for a LAN connection that you could have. So, you can see how the entire bandwidth would be or the line capacity would be shared. There will be a constant bitrate applications which use up a constant amount of the line capacity. Then you have a variable bitrate application which uses some amount of the line capacity. Whatever is left out, right, this is what is available for the two service categories, which is ABR and UBR. Okay. So, here in variable bitrate category, both real time and non real time variable bitrate applications will use up this bandwidth. Whatever is left out beyond that will be used up by ABR and UBR. ABR, at least you have some guarantees to be provided in terms of this is the minimum cell rate to be specified and supported and so on. Unspecified bitrate is totally unspecified, in the sense that whatever extra is available can be made use of. Okay. So, this is how the entire bandwidth is shared between the different service applications. So, in terms of the different traffic parameters and service and the QoS parameters that we have, constant bit rate you can look at it as the traffic parameter specified there is PCR, and the QoS parameter there is low cell loss and low cell delay. With respect to real time VBR, you specify a peak cell rate, sustainable cell rate and maximum burst size, and QoS parameters are in terms of low cell loss and low cell delay. For a non-real time variable bit rate, traffic parameters are PCR, SCR and MBS, maximum burst size, and again QoS in terms of low cell loss but high cell delay, which meaning that cell delays can be tolerated. With respect to UBR, no guarantee in terms of traffic parameters, so no parameter specified. High cell loss, high cell delay, which means you could have high cell losses and delays also could be more. ABR, as we said, we specify PCR and MCR, peak cell rate and minimum cell rate. Low cell loss, high cell delay can be tolerated. Okay. So, this is how using the various traffic parameters and the quality of service parameters, the different service category requirements are specified. Now, coming to traffic management, okay, how is it that the management of traffic actually takes place? ATM provides for various schemes. Okay. It has something called a connection admission control, which is used for connection management. Then it has something called policing, which is used for making sure that the user is not violating his side of the contract. Then you have a cell loss priority control, which is taken care, which takes care of the loss in the cells and the priority setting of priorities for the different cells. Then we have a frame discarding policy and we have a traffic shaping policy. Traffic shaping is to make sure that if you have opted for a particular data rate, a cell rate, you make sure that the traffic is shaped to cater to that or to agree to that particular rate. So, you have some traffic shaping mechanisms which are provided. And then of course, if there is congestion, there is some congestion feedback also that is provided, which is used for the ABR traffic. So, for traffic management, actually it is a very extensive set of mechanisms that are provided by ATM. We will just take a brief look at one or two features of this. Okay. So, if you look at the connection admission control, okay, you can see what is happening in this case. So, basically a user says I want a virtual circuit with x megabits per second, y delay, z cell loss. So, he specifies his parameters. Okay. So, we have now a contract between, we need to decide whether we can make a contract between the user and the network. Now, what the ATM network does is, when there is a request with this quality of service, a guaranteed QoS request that comes over here. So, the connection admission control part of the ATM network says, can I support this reliably without jeopardizing other contracts, without spoiling other contracts, can I support this contracts? If he says yes, then he agrees to the contract and now data can be sent. Otherwise, he says no, that I cannot provide this particular contract, which means this connection will not be admitted. Okay. So, there is no question of admitting a connection and not providing the services. So, you make sure that you are able to guarantee that the whatever requested quality of service is there before you agree to the contract. Okay. So, this is our connection admission control mechanism. Okay. So, what we are essentially doing here is you determine whether a connection can be progressed or not, satisfy the traffic contract of the connection and not disturb the traffic contracts of the other existing connections. This is also important, right. So, as long as both these are satisfied, CAC will go ahead and admit the connection. Okay. Now, coming to UPC, which is our usage parameter control. So, what we do here is, okay, so we already have a contract that has been signed by the user saying I am going to send data at a particular rate, some peak cell rate or sustainable cell rate or whatever. So, what the usage parameter control mechanism does is, as data is coming in from the user into the network, it looks at the data and says, are you in conformance with the contract? Are you really sending data at the rate at which you were supposed to send? Okay. So, what should the penalty be? If you are not in conformance with the contract, should I give you a penalty? Should I drop your packet or pass the packet, pass the cell, but maybe mark it as cell loss priority, which means this particular cell is in violation of the contract, but if there is still some bandwidth available, it can go through. But if there is some congestion in the network, then I will drop this packet. So, this is what we use the cell loss priority bit for. If you set the bit to 1, if necessary, this packet can be dropped, that is what it means. So, that kind of setting that particular CLP bit, these things will be handled at the interface between the user and the network. So, we have this usage parameter control mechanism which takes care of doing this. So, you can see it is kind of seeing whether you are meeting the particular contract or exceeding your contract parameters. So, what we do here therefore is it's based on the traffic contract of the connection, and the action that we do is either you discard the cell, you may drop the cell, or you will tag the cell. Cell tagging is by means of this priority bit that we talked about. So, if you have tagged the cell, it means that this is a cell which is sent by a misbehaving user. So, this could be dropped if necessary. So, next is congestion control. So, how is it that congestion control is handled by the network? Okay. So, what happens when congestion happens is that the network, right, when it receives receive data from different sources, because of congestion it could start dropping packets which have the cell loss priority bit set to 1. Okay. But when it does that, what it also tells is, it tells everybody on all the connections, okay, it sends information saying I am in congestion, okay. So, I am dying, in the sense that I am dying. So, please do not make a connection to me. Okay. So, this information kind of goes out as part of the bits that are sent as part of all the cells that are sent on all connections. Okay. So, congestion information is conveyed to all connections. This is again part of the traffic management that is done. So, this is normally handled with the help of this cell loss priority control again. So, if you look at the cell loss priority control, in the congestion state, we have a bit called explicit forward congestion control, or EFCI as it is referred to. That is, when I am in congestion, I set this bit on all the bits on all the cells that are sent through me. So, this information when it reaches the other end is an indication to the end users that my traffic is going through switches which are already congested. Okay. So, with the help of this EFCI, then the end machines can decide to lower the rate at which they are sending in data. Okay. So, this is called as a congestion forward congestion control, that is it is an explicit congestion indication that is given by the network. And then of course, we have seen this use of the cell loss priority bit, where you can set this cell loss priority bit to indicate that this particular cell can be lost in case there is a problem. Okay. So, this is how we take care of the various traffic related issues. Okay. Now, if you look at a switch, what actually the ATM switch looks like, we said that it is typically conducted in terms of, it is constructed as a hardware device. So, if you look at what actually goes into a switch, you will find that these are the components that you have. So, you will have a data coming in through multiple ports. There are what are called as input controllers which control the data coming in, which goes into a switch fabric. Okay. And then you have output ports which again are controlled by means of output controllers. There is a control processor in between which takes care of configuring the switch and making sure that the switching takes place correctly. Okay. So, this is typically constructed in terms of using VLSI circuit. So, it is basically a hardware based switch that is used. Okay. So, example for a switching fabric topology may look like this. Okay. For instance, you have switches, the switches could be in two different modes, a crossover mode or a straight mode. So, you could configure the switches appropriately. So, you have different interconnections between the various switches that you have, and using this kind of switch, by configuring each switch appropriately, you will be able to switch from any port to any port. Okay. This is how the switches, the ATM switches are basically constructed. Okay. So, to summarize, what we have looked at in today's session is that we have looked at different service categories and the different adaptation layers which provide for these service categories. We have also looked at how traffic management is handled in ATM networks, and in terms of traffic management, we saw how we do connection admission control, we also saw how you do traffic policing, okay, and we talked about how in case you exceed the capacity of your contract, what is done to your packets. Okay. So, this should give you a basic idea on the characteristics of ATM. Is a very large protocol. So, it is very difficult to look at the whole of ATM, it is a special course in itself. So, it is very difficult to look at it in just 1 or 2 lectures, but these 1 or 2 lectures is basically meant to give you an overview of ATM. Okay. So, questions again for you to look at today's content. Question number 1, what are the functions of the AAL layer? Question number 2, name the different service categories supported by ATM. Question number 3, what is ABR? Question number 4, what are the functions of traffic management? Question number 5, what is cell loss priority? Thank you.